Assalamualaikum. Today I would like to do the presentation titled Simple or Multiple Linear Regression. For the introduction, SLR is Simple Linear Regression, which means it has single input variable. Meanwhile, MLR is called Multiple Linear Regression because it has multiple input variables. For the next slide, as you can see, the data that we use is data set number 1. Okay, for the next slide is 2.1. 2.1 is scatter plot, consists the data of set number 1. The scatter plot has been divided by each variable, which is x1, x2, x3, x4, and x5. Okay, for the next slide is 2.2, which is correlation coefficient. As you can see on the slide behind me, R equivalent to 0.997 has strong positive linear relationship and consists R square equal to 0.993. It means 99.3% of the variation on the annual net sale is accounted by the variation in the independent variable.
In general form of SLR equation, we use formula y equal b0 plus b1x, where this formula used for all data from x1 until x5. Based on this equation, y represents dependent variable, b0 is constant, b1 is slope, and x is independent variable. 2.4 testing the regression slope b1. There are tests of significant anti-relationship with y. We take one data x1 0.05 for significant level. The statistic is 9.981. P-value is 0.001. The hypothesis is rejected and the relationship with y is significant. 2.5 coefficient of determination. We took one example for data x1. R equal 0.894. R squared is equal 0.799. Denotes that x1 accounts for 79.9% of the variation in the while the remaining 20.1% is unexplained and is regarded as the coefficient of determination.
Next, I'm Shamimi will be present about overfitting. These are the two outcomes. Since R square for all the independent variable is 0.993, which is larger than 0.5, so it means the data have overfitting. For each variable, the lowest for each variable is x1.
Next is multicollinearity. The coefficient of x1, x2, x3, x4, and x5 are displayed in the table above. It is demonstrated that the VIF for x2 is greater than 10 or 10.122, indicating multicollinearity. The other dependent variable becomes more significant and multicollinearity disappears if x2 is removed. For the model comparisons, models are selected according to their R2. In comparison to R2 for x1 is 0.79, x2 is 0.89, x3 is 0.83, x4 is 0.91, and x5 is 0.83. MLR's R2 is 0.99. The R2 that it lists is 0.79. Better models have greater R2.
Assalamualaikum. I will talk about 3.9, the best fitted model. The MLR is a statistical technique that estimates the outcome of a response variable using several explanatory variables. Is the better fit model for MLR and SLR. The linear relationship between explanatory and response variable is modeled using multiple linear regression attempts.
There is a correlation between a continuous dependent variable and independent variable which differentiate with a number 1 until 5. The MLR makes number assumption, not much correlation between variable, means, variance, and normally distributed. R squared is a statistical metric that assesses how much variation in independent variable.
1.11 hypothesis testing. For x1, x2, and x5, we accept the null hypothesis because the p-value are less and same with signification level. Then for x3 and x4, we reject the null hypothesis because the p-value is more than signification level.
As conclusion, MLR deals with the intricate relationship between the data that can be explained by multiple variables. As a result, we can analyze the data. For advantage, MLR can do data analysis for more variables of data, determine relative influence of predictor to the criterion valuability, and identify outliers. So that's all for our presentation. Thank you.